All right, today we are diving deep into the really complex world of inflammatory bowel disease, or IBD. We're going to explore some of the key molecular targets that are totally changing how we think about treatment. Moving beyond just handling symptoms and actually going after the inflammation at its source.
So let's just start with this big what if question. What if the real key to getting a handle on autoimmune diseases like Crohn's and colitis isn't just fighting the fire, but finding the master switch that starts it all? That's the core idea we're going to unpack right now.
Okay, so let's get into it. First things first, we got to understand the problem we're trying to solve. What exactly is inflammatory bowel disease? At its core, IBD is basically a group of chronic, and that means long-term conditions, all about inflammation in your gut. Now, the two you've probably heard of the most are Crohn's disease and ulcerative colitis. And even though they seem similar, they're actually pretty different. And this is where it gets really interesting. Crohn's disease? Think of it like a guerrilla warrior. It can show up anywhere in the GI tract, from your mouth all the way down, and it creates these patchy areas of inflammation that can go really deep. Ulcerative colitis, on the other hand, is a bit more territorial. It sticks to the colon and rectum, and the inflammation is continuous, just right there on the surface lining. So, what kicks all of this off? Well, from what science tells us, it's basically a perfect storm. If you've got a certain genetic makeup, your immune system can just overreact to the normal, everyday bacteria in your gut. Instead of just keeping things in check, it launches this massive, non-stop inflammatory attack on your own body. Which brings us down to the molecular level. I mean, if the immune system is the army, who are the generals shouting the orders? Let's take a look at inflammation's key targets. Yeah, if we really want to find smarter ways to treat this, we have to ask, what specific molecules are sending out these inflammatory text messages? Pinpointing them is step one. Figuring out how to block them is step two. And here they are. Meet the two main ringleaders, interleukin-12 and interleukin-23. These guys are what we call cytokines. They're basically signaling proteins. Think of them as the key instigators that call in the troops and rile up all the different immune cells, really orchestrating that whole chronic inflammation mess you see in IBD. Now, this is where the strategy gets really, really clever. It turns out that both of these super powerful cytokines, IL-12 and IL-23, they actually share a building block. It's a protein subunit called P40. And because of that, P40 becomes this incredible target. If you can block just that one piece, you shut down two of the biggest inflammatory signals at once. It really is like having one key for two different locks. And this quote right here, it just perfectly explains how modern biologic drugs do their thing. These medicines are basically custom-designed antibodies that are programmed to hunt down, grab onto, and neutralize that shared P40 subunit. When they do that, they stop IL-12 and IL-23 from ever delivering their inflammatory message. But, and this is a big but, this approach isn't a silver bullet, not even close. As you can see, a pretty big chunk of patients either don't respond from the get-go or the drug just stops working for them over time. Then you add in the crazy high cost, the fact that you need injections, and the potential for side effects. Well, you can see why the hunt for other options is so important. So that gets you thinking, right? Do we always have to use this pharmaceutical sledgehammer? Or could there be other ways, maybe more subtle ways, to influence these exact same inflammatory pathways? Okay, let's switch gears and look at our first alternative. We're going to start with krill oil, which takes a much, much broader, more systemic angle on calming things down. So krill oil comes from these tiny little crustaceans, and it is just loaded with good stuff. The main headliners are the omega-3 fatty acids, EPA and DHA, and this really powerful antioxidant called astaxanthin. And it's how they all work together that's so interesting. Okay, I know this diagram looks like something out of a chemistry textbook, but hang with me. The real takeaway here is just how much it does. See, unlike a drug that hits one single target, the stuff in krill oil is more like a system-wide modulator. It dials down some of those master inflammatory switches, but it also fires up your body's own antioxidant defense systems. It's less of a block and more of a rebalancing. So, to put it simply, you can think of it as a three-step process. First, it quiets down those big, broad inflammatory signals. Then, that leads to less production of the actual inflammatory molecules. And finally, and this is really cool,
It actually helps your body's own cleanup crew get better at its job of resolving inflammation.
All right, so we went broad with krill oil. Now let's get super focused. We're going to look at a compound from a plant that takes a really targeted shot at one specific inflammatory pathway.
This is andrographolide. It's the powerhouse compound from a plant that's been used in traditional medicine for ages. And what has scientists so excited about it now is how it seems to specifically interfere with that IL-23 pathway, a pathway we know for sure is a major troublemaker in IBD.
Okay, let's zoom in on this for a second. Remember how we said IL-12 and IL-23 share that P40 subunit? Well, IL-23 also has its own unique partner called P19. So by targeting the P19 pathway, you can shut down IL-23 specifically without messing with IL-12 at all. And that's a big deal because IL-23 is the main thing that activates this whole army of highly inflammatory immune cells. If you can quiet that one signal, you can stop the whole waterfall of inflammation that comes after it. And look, here's the proof in the pudding. What you're looking at is called a Western blot. It's basically a lab technique that lets you see specific proteins. See those dark bands in the LPS column? That means high inflammation. But then look what happens when you add andrographolide, or AG. The bands for IL-23 and all its downstream signals just get fainter. It's a visual confirmation that it's toning down that whole pathway. So the big takeaway, the thing to really get here, is that andrographolide isn't just a simple off switch. It's more like it's turning down the volume knob on the entire signaling process. It's inhibiting the whole cascade, which reduces the total inflammatory noise. So after all that, where does this leave us? I mean, what does the future of managing something like chronic inflammation actually look like when you put all these different ideas together?
Let's just compare them side by side. On one hand, you've got the pharmaceutical biologics. These are the big guns, super potent, incredibly targeted, designed to just completely block one specific thing, like that P40 subunit. And on the other hand, you have these natural compounds that just work differently. Krill oil tries to restore balance across a bunch of pathways, while andrographolide inhibits one specific axis to dial back its output.
And that brings us to the final thought. Maybe, just maybe, the ultimate goal shouldn't just be to block inflammation at all costs. Maybe it should be to restore the immune system's natural balance. Because as we've just seen, there's more than one way to get there. The future is probably going to be all about finding the right path, or maybe the right combination of paths for each individual person.